In this video, we're going to take a look at solving some simple inequalities. Now, first of all, it's important for us to understand that the difference between an equation, for example, something like 2x minus 4 equals 2, and an inequality, 2x minus 4 is greater than 2, is simply the fact of the symbol that showing the relationship between the two sides. In 2x minus 4 equals 2, I am looking for the number that will make both sides equal to 2. In 2x minus 4 is greater than 2, I am looking for the numbers that will make 2x minus 4 greater than 2. So that in itself is a big difference between equations and equalities. Now, as far as solving an equation, all I have to do is like we've always done before, add 4 to both sides, so 2x equals 6, divide by 2, and x equals 3. Solving an inequality is actually identical. I'm going to add 4, so 2x is greater than 6. I'm going to divide by 2, so x is greater than 3. So my solutions look slightly different, but how do I really interpret those? A number line helps us. If I wanted to graph the solution to my equation on a number line, I would have 0, the center of my number line, 1, 2, 3, and I would just put that single point at 3. That represents that is the only solution to that equation. That's the only number that I could plug in for x that will make both sides the same. Whereas in my inequality, if I wanted to graph the solution to my inequality on a number line, I would have 0, 1, 2, 3, and at 3 I would put an open circle, and then I would shade all of the numbers to the right of 3 since the solution says x is greater than 3. Now that means I can take any number to the right of 3, plug it in for x, and that would make this inequality true. So let's try that process once again. So I'm going to start by adding 3 to both sides, add 3 to both sides. So now I get 4x is less than or equal to 2x minus 2. Now I'm going to subtract 2x from both sides, subtract 2x from both sides. So now 2x is less than or equal to negative 1. Divide by 2. Oh, that should be a negative 2, not a negative 1. Divide by 2. X is less than or equal to negative 1. So there's my solution. Now if I wanted to graph my solution on a number line, draw my number line, 0 at the center, negative 1, and then I would put a closed circle at negative 1 in this case. So I would have a closed circle at negative 1, and I would shade the values to the left of negative 1 to show that this was less than or equal to negative 1. Now the closed circle was used in this case to show that negative 1 is part of my solution. If I plug negative 1 into the original, the two sides of the inequality would be equal, and since this can be greater than or equal to, that would work in this case. There is one very important difference in solving inequalities, and that will take place in this solving inequality problem. So I'm going to start by subtracting 7 like normal. Negative 2x is greater than negative 4. And now the issue with solving inequalities is anytime you divide or multiply both sides by a negative number, everything stays the same like solving an equation. However, my inequality sign needs to change directions. So rather than this being x is greater than 2, this is now x is less than 2. So that's the one major difference in solving an inequality between solving an equation, other than the graph of the number line itself and the graph of the solution, is that when we divide by a negative number, the inequality sign has to flip directions. So I'll put my open circle at 2 again, I'll shade to the left, and that would be an appropriate graph of my solution.